experiencing the same thing, that boron is not completing its octet, as it has 6 electrons in valence shell. Now I'm drawing the geometry of BF3. So there are 3 atoms which would push each other as far as possible, and the possible structure is this trigonal planar, which means that the atoms would have 120 degrees bond angle and would remain as far as possible, and the geometry would be called as trigonal planar geometry. Trigonal planar means it would be in the same plane. The atoms would not move out of the plane or inside the plane, so it would remain in the plane. Let me show you an example of trigonal planar. This is an example of trigonal planar. Here, this is the central atom. It's in one plane as we can draw on paper. So it would not, this angle is 120 degrees, and this is all 3 angles would be same and 120 degrees and try to be as far as possible, and the geometry would be called as trigonal planar. Now I'm going to talk about another example. Here we have 2 atoms around the central atom and 1 electron pair. I wrote SO2 as an example. So here I have SO2, and I'm writing this molecule as this. These electrons on oxygen would not affect the geometry, but the electron present on sulfur would affect the geometry of this molecule. As we talked about that it have 3 electrons, 3 things around the central atom, so it would have a trigonal planar geometry, basically a trigonal planar, but in actual it is not trigonal planar. Let me show you this. This electron pair would push the oxygen atoms and bend it a little bit like this. The unshared pair of electron is not going to be counted as in geometry, but it would have an effect on the geometry of a molecule, because the electron pair is very strong and would push the atoms closer to each other. So the trigonal planar molecule, like this, I have this trigonal planar molecule, but in this case we have this atom replaced by an